So hi everyone. You all had fun at the barcade last night? Yeah? How many of you grew up with those classic games? All right. Now how many of you wanted to enter those games? Pulled the full Kevin Flynn from Tron? I know I did. And I hope you can appreciate my talk on it called Getting Started in VR with JS, also known by The Dream of the 90s is Alive. And like virtual reality permeated the 90s, right? We had all kinds of movies featuring virtual reality. It was TV shows, books. We even had music videos starring 90s it girl, Alicia Silverstone. And for a chubby foreign kid growing up in a part of Canada affectionately called Chemical Valley, with strict parents, very few friends, and always escaping into those movies, TV shows, music videos, books, video games, and this dorky thing called programming, virtual reality was this big dream, right? It was the dream of truly escaping, the dream of creating worlds, and the dream of sharing it with others. And I know exactly when it began for me. In 1991, with this amazing ABC primetime live report on virtual reality. These graphics blew my mind. You can still find this video on YouTube. And I also know when it died for me, only 4 years later, when after months of this badass 90s marketing, I was so ready for this bad boy. And I finally heard it was available, so I went to the best tech store in town and tried it out. And to this day, I don't know why I started crying. Was it because of the eye-straining, tiny red LCD screens that just didn't work, or the fact that it just plainly sucked, and more importantly, it seemed like no one else cared. No one bought it. There was no enthusiasm for it. So over the years, I eventually just gave up on VR and 3D games and stuck to the old web application development. 20 years later, I'm incredibly old. The cyber matrix verse, it happened, right? It happened in the World Wide Web. Thanks to JavaScript, we can real-time chat, we can do streaming video, we can share, we can overshare. But it didn't really happen, right? Not in the full promised 3D head-mounted glory that we all wanted. Until 3 years ago, when Oculus literally kickstarted the whole current VR craze. And I didn't care. I mean, followed the news, read all the stuff, but I really just wasn't getting back into it. Because like anyone contemplating getting back together with an ex, you wonder, why would this time be any different? So it wasn't until Carbon 5, the product design and dev shop that I call home, bought a few headsets for us to mess around, that I started exploring. We have a culture of experimentation, and while web apps and mobile apps are our bread and butter, we always try to see what's next. And more importantly, see what's next with what we already know. So my friends and I began to investigate virtual reality. And what we found is that JavaScript, a tool we used every day, is an actually excellent way to start building VR experiences, particularly through a technology known as WebVR. And what I'm going to do today is show you some WebVR, walk you through some code samples, talk about the UX challenges you'll face, and then give a bit of a roadmap for how you can get this stuff out to a lot of people. But the first step is you need to get the gear, right? A year ago, this simply meant buying an Oculus, but a whole bunch of other devices are about to hit the market. Now, all these devices have varying functionality, varying interfaces, and supporting it all is something we'll discuss a bit later. But there is a concept of a least common denominator headset that they all kind of have to match. A headset has to deliver position data to your app. Your app now is responsible for generating what's known as a stereoscopic view. That is, a left and right eye vision of the world you are trying to deliver to your users. Then the second responsibility of the headset is provide a surface to display the stereoscopic image on. So that any users looking through the headset have it projected around their eyes, and then their brain does their natural function of producing that into a 3D image. And then their minds are blown, so that's amazing. So, a device that gives positional data and a surface to draw on. This sounds awfully familiar, like a thing we all have in our pockets, called a smartphone. And so smartphone technology, obviously the technology that goes to smartphones helped make Oculus possible. But the idea behind Google Cardboard, this really cheap headset that started out as a joke by Google, but they're really pushing forward, is that, well, why not just provide this simple harness that people can slip in their phones with an app already loaded, and they can start experiencing VR. So these things are really easily acquired, easily accessible. In fact, they're producing more serious versions down the line. But I'm going to help you guys with that first step. I'll be giving these Google Cardboards out during the Q&A lounge and throughout the conference, as will some of my Carbon 5 friends who are here. It's going to be fun. So, in exchange for giving out these cardboard devices, I'm going to beg your forgiveness, please. Unfortunately, I'm not going to be doing a live demo or live coding, or live anything, apparently, of VR up here. Given all the software you need to get started, and all the cabling and hardware, and the AV issues that could happen, we did not want to tempt the VR demo god and his wrath. I will also be doing some demos on request during the Q&A lounge or throughout the conference. I brought all the equipment. Demos are available at c5vr.com along with the source code. So next step is you got to download all the things to see the demos. The drivers, and you have to get WebVR browsers, of which there are two. You can find the Firefox instructions, which is just their nightly, the next dev version of Firefox, at mozvr.com/downloads, as well as a lot of demos. And I have provided a link to go and get the Chromium version that supports WebVR. Which leads to the question, what is WebVR? I'll tell you what it's not first, okay? WebVR is not some sort of virtual reality DOM model, right? You don't define... I stole this from a React slide. That's the best part about it. So it's not a virtual reality DOM model where you define objects using tags and they have events on it, though that was the idea of VRML. And interestingly enough, Tony Parisi, one of the creators of VRML, is actually writing a book on WebVR and providing a nice framework I can encourage people to look at called GlamJS that returns those concepts into your browser. It's a JavaScript framework. However, it's all built on top of WebVR. WebVR is not a WebGL replacement. It's not a 3D engine itself. WebGL is a low-level framework that's available in all browsers that lets you build your own 3D rendering pipeline. But I got to tell you, math is hard. Coming up with a pipeline to transform points in virtual space all the way to pixels and colors it and all kinds of transformations, I don't want to do that. Luckily, Ricardo Cabello and his team on 3JS have provided this wonderful framework. You probably have heard about it. And first piece of advice, go use 3JS. It has a really high-level abstraction around all the WebGL stuff and makes it so easy to use, and you can quickly generate 3D in your browser really simply. Now, I'm going to walk through the code of this simple 3D scene so that you guys can see, when we get to the VR part, how easy it is to convert it. It's really simple. So to begin with, here's the HTML. If you look through it, nothing much happens. The key point is you get your 3JS script in there, and you also, of course, have your app code. Now, the first thing you want to do is create what's known as a renderer, specifically a WebGL renderer. You basically set it to the size of the screen, and the renderer is going to draw everything at the end of the day, on every frame. And in exchange, it provides you the DOM model that you have to, or the DOM element you have to add to your document, which is a simple canvas. The next thing you have to do is make a scene, which usually means standing up in public, screaming to your head out loud, and maybe possibly slapping a person. Back in the day, it's so easy now, you just do this one line of code. All kidding aside, a scene is the world you're creating on a whole. Everything has to be added to the scene in order for it to be part of what gets rendered. And one of the first things you also need is a camera to see into the scene. Next, you're a god creating a world, so you let there be some light. In this case, we create a very simple light at the center of the entire world, which is where your camera starts, and again, add it to the scene. Without light, you're not going to see anything. Of course, currently, we don't have anything to see, so we got to add some other objects. These are known as meshes. Meshes have a geometry, that is a shape, and also a material, which think of it as the skin or the coloring on it. As you can see here, I created dodecahedron, which is that blue thing bouncing around, and colored it that light blue. And then I positioned it a bit away from the camera and added to the scene. I also created that ground floor that you see there. It's just a big flat plane in blue. And notice that it faded off in the distance. That's our light taking an effect. Now we want to start animating this, and animation is really simple. Define a function, tell it how it should move things in this world. In this case, I'm bouncing the thing on the x and y axis and rotating it around its z and y. And finally, that renderer we created, you tell it to render the scene as seen through this camera. And that's it. Boom, the 3D image appears. To get it animating, you hook into the next animation frame with a request animation frame callback, which passing the animate function as the callback. And you kick the whole thing off with animate. So, pretty simple, right? And all we need to do is apply some web VR, and wow, we're in virtual reality. So here you can see it in action as it's bouncing around. And if you notice in the corner there, we have the live feed of the helmet going up, down, right and left, and notice how the whole thing shifts and changes. The flickering is the projector and not my wonderful VR demo. So that's really easy to get that done. Now, I haven't still not told you what WebVR is. Well, WebVR is a proposal being led by Vladimir Vukicevic and Brandon Jones and their team to provide a device interface to VR headsets. That is a way to detect and poll head-mounted displays and other positioning reporting devices. Now, the enter point is really simple. It's this get VR devices, and through a callback or promise, it returns a list of the devices but grouped into two types. The first type is position sensor VR device, which tells you information about the orientation and position. Then there's the HMD head-mounted display VR device, which tells you like you have a surface you can draw to, and it can also give you information about the wearer's eyes, where their eye line is. Notice these two match the two responsibilities that the headset has to happen. And in fact, when you have a single headset, it reports as two different devices. So getting all that data and using it to manipulate the camera and doing all the stuff, well, math is hard, But luckily, 3JS comes to our rescue again. I got to tell you, all the web VR demos out there, for the most part, use VR controls and VR effects, two scripts that are available in the 3JS examples within their source code, particularly the dev branch. There's actually a lot of other awesome utilities that you should check out. So how do we use these? Well, I'm going to walk you through, again, how to put it in your own code. And I want to pay attention to the fact that what you do in your own code is very small. In fact, but I'll dive deep into VR controls and VR effects so you have an idea of how it interfaces with the actual web VR interface. So here's the basic HTML, but all you need to do is drop in the control and effect script. They're not part of 3JS. They're their own distinct thing. So after you create the camera, the first thing you're going to do is create your controls, and you pass it the camera. Why? Well, VR controls wraps around the position sensor device and manipulates the camera based on that information. And I pulled out the core part of its initialization, so you can see here. They create the callback function, which takes the list of devices and simply iterates through them and filtering them out, looking for position sensor VR devices and saves them. And if you notice down there, it uses the promise interface to pass that function in at the bottom. When you get VR effect, you do the same thing, but it gets the renderer, because VR effect is the one that's going to be responsible for drawing. And if you get to my next slide, it's the wrapper around HMD VR device. And its initialization is the same. Look for HMD devices. Now notice that ... in there? There's a whole bunch of code that goes in there. This is just a brief part of it, but you can use this information to gather about the user's eye line, like I mentioned, and we do need it when we get to the part about drawing it. Well, VR effect needs it when it gets to drawing this interface. So back to the basic example. You also want to go full screen, as you notice, because your VR device, at least when it comes to Oculus, is another monitor. That's how it sees it. So you have to take over the whole thing. VR effect provides a nice facade over the varying different browsers' way of getting into VR. And also, they're extending the request full screen. And if you notice the two versions there that have the browser prefixed, to actually pass in the VR display. Because WebVR will go, oh, this is a VR? I'll help render this in a better way to take into account the bending of light when it comes to being displayed on a headset. OK, later on, you get your animation function. And everything's the same, except we replace the renderer render with this controls update to go and get information to poll the devices for the position information and apply it to the object. The object, in this case, was the camera you initially passed in. But they leave it to be flexible because maybe you want to use your head, you want to turn your head, but have an object rotate in front of you as opposed to the camera moving. Then, to draw the stereoscopic view, you tell the effect to render the scene and the camera. Now, the code that happens for this function is really verbose, but it's actually, when you get down to it and read through it, it's really simple in what it does. It basically replaces the main camera with two other cameras that represent the eyes. So it basically copies over the positioning and all the orientation information to generate the left camera and the right camera, and then moves them a bit based on that eye information that VR Effect had collected earlier. And that's it. It just renders them on like half the screen. It's really simple, but it works and gets the job done. So I got a terrible confession to make. None of this works on that Google Cardboard device that I'm going to be handing out to anybody. And that's because WebVR is still in development. You have to download special browsers for it. However, the community comes to our rescue again. Boris Mus, who I'm hopefully pronouncing the name correctly, has provided this polyfill library. And it's very clever. It just takes the device motion interface that HTML5 has and wraps around it a fake position sensor VR device and passes that in. It also can hook into your mouse, your keyboard, and use other mechanisms to fake having VR. He also provides this excellent WebVR boilerplate, which is a template for getting started, and also has some other useful classes for managing your VR state, and also keeping your browser alive, in the case of your phone, as it'll go to sleep if you don't touch it for a while. How do you incorporate it? It's so easy. You drop it in, and that's it. All the code I showed you before works. Nothing more to it. So I hopefully know what you're thinking at this point, which is, this is all great and wonderful, and I'm really glad I can see really simple shapes in space, but I want to do more complex things. I want to, create a whole reality matrix style. And I got to tell you, I don't see why you need to do that. It was good enough for Tron. It should be good enough for you to stick with simple shapes. But all kidding aside, there's one thing, before that, I have to say, you can actually get a lot of distance from 3JS. They provide a lot of libraries for you. So this was a model loader. Hopefully you can see the texture mapping on the ground below. And you can, if you go to the 3JS examples website, they do some mind-blowing stuff. But in the case of VR, the one thing you have to watch out for is simulator sickness. This is what you keep hearing about when people feel like they go into VR and they feel sick. It's all due to not either hitting your frame rate or lagging behind the data information because you're spending all your time trying to calculate data. So your motion data is already laggy right from the get-go. And if you're working in a browser, as we all know, sometimes JavaScript is not as fast as a native experience, so you're maybe at a bit of a disadvantage there. And the more graphics you try to push through the system, the harder this is going to be to hit that frame rate. So a lot of people are paying attention to 360 video as the first mechanism to do that. Because if you think about it, you get a high-fidelity view of the world. I'm not going to go into how to record this. Just know that you get a video file like this where it represents each eye, and you then have to spherically map this to this video around each eye. Now, math is hard, so I'm not going to talk about even how to pull this off, but there is an example in 3JS, and there's a great other library called LEVR Web Player that doesn't use 3JS. They go straight to WebGL to pump this out as fast as possible. So great stuff there. Moving on to interaction. I've been talking a lot about how you can look into this world, but the dream is to reach in and start manipulating things. We're in the browser, so we have access to all the HTML5 interfaces to keyboard, mouse, gamepads now. Some people can even talk about using speech interfaces. But to fulfill that dream of actually touching that world, you got to go with Elite Motion, right? There's Elite Motion mounted on an Oculus headset. And they are really embracing this whole thing. In fact, they're working directly with 3GS. They're not going down to WebGL level. They make this stuff really easy to just drop in. And so here's the demo. If you can see my hand moving in the top there, and then it's being reflected in the space. And this is all in the browser, using JavaScript, nothing special. So it's pretty cool when I show this presentation live to people, they're like, whoa! So pretty fun. Getting it working, again, nothing really changes except drop in more libraries. But here's the entire code that made that happen. You start off pinging your Elite Motion device. You then tell it you want to start transforming the data so it goes into VR space and in relation to your camera. And then they actually provide that hand model. And it's up to you just to add it to the scene by saying the scene is its parent and applying the materials. So all the same concepts go in there. Which leads to confession number 2. This also doesn't work in the mobile. Without hacks, that is, or using really, really beta software. So some people set up a Node.js server, and they have the Leap Motion on their desktop, and their mobile device pings it. That's insane. Don't do that because of the lag. It'll eventually get there. But there's this problem, again, of, well, there's all these different devices, and they all have different ways of interaction. Even the cardboard has a small button on the side, like the classic ViewMaster. So how do you create a VR experience that's guaranteed to work on all these things? Well, there's one interaction that actually is on all these things. Your gaze. Where are you looking? Where you're looking, you can trigger off different changes to your object, to your world, or even the storyline. There was a VR experience attached to a movie called The Wild that hit the scene, and it was really interesting because while it was a video VR experience, what happened is as you're in it, depending where you look, would suddenly change the flow of the video. They would load something else and change the storyline. So if you stare too long at Reese Witherspoon, she kind of gets creeped out at you and says, go away. If you look in a different direction, Laura Dern pops out. If you look behind you, a deer shows up. And so it was an interesting way to create a unique experience, but with something that everyone thinks of as very static, which is video. So let's add some interaction to this. And here I'm just doing a simple gaze demo. If you look at the model head-on, it will actually either turn red or green, red or yellow, and change its geometry as a result of it. Really simple. How do you pull this off? Raycasting. 3JS provides this raycaster, and you basically, if you think about it, tell it to draw a ray coming out from the camera and detect if it intersects with anything. Here, I'm creating that raycaster, saying, make it from this camera. You have to give it the center of your screen so it knows to draw it from the dead center. And then you give it the objects you're interested to detect. In this case, the single bit that's floating around. And that's it. So all of this interaction talk kind of ties into an idea that Boris Muss had put out called responsive VR. How do you make an experience that can work on all devices? Now, he was talking about it in terms of technology, but I want to bring out the idea of that, what if it's not technology? What if it's also the experience itself, right? What if you have a simple experience for the really simple devices that's more of a roller coaster ride? But then if you detect all these different, the different functionality, you can go all out. Think of the simple version being the mine ride in Indiana Jones and Temple of Doom, where you look could maybe trigger which path your mind goes down. But then if you have the handheld controllers, you can grab the whip and start cracking. So building all that, math is hard. This gets really hard when you start building out game engines. Now there's several game engines out there. I'm going to use Unity as an example of one. Unity, for a long time, allows you to publish to multiple platforms natively. And there's a whole bunch of VR plugins that let you build out for Android, build out for iPhone, and build out for the Oculus. And apparently it's all going to be baked in. 5.1 is the rumor. All those concepts I've been chatting about here still apply to Unity. All the terms apply. This is the Unity editor, and in the center is the scene. Here's a camera. And on the camera, this is a script that is attached to it that comes from the Android Cardboard plugin that basically does the same thing that VR Controls and VR Effects does. It says, move the camera based on how the device is moving, and also render it into a stereoscopic view. So where does JavaScript come into play here? Well, on your objects, and this, again, it's a mesh, you can actually add JavaScript files that control the behavior of the object. Now, I say JavaScript, but when you take a look at this code, it's actually what they call is Uniscript. But this actually looks a lot like the typing code that hopefully will be demonstrated later in this conference. But it's very simple. On update, you tell it how to rotate it. And the other function I wanted to show you is other script was much more complicated, but it has the same concept of array, an array caster. You send it out, you figure out what it hits, and you do something with that information. So there's this interesting idea that started forming in my head, which I haven't done yet, but I'd love to encourage people to go and try it out. Unity now exports to WebGL. That is, it exports your game to an HTML5, with WebGL as being the rendering system. So what if we were to build a WebVR Unity plugin that bridges to the WebGL projects when you publish to WebGL? Now you can design an experience once with all this rich interaction, and then publish it to natively or on the web or what have you, and run it anywhere. And now you're playing with power. There's a lot of gotchas here. Simulator sickness, again, is real. It's going to get better, but in the meantime, maybe your first examples is to create really simple motion interactions. 3D modeling is hard. I spent a lot more time trying to find models or edit models to make them fit in my world for what I wanted to do. And I actually got some interesting advice finally from a developer called Dave Taylor, who was one of the developers behind Quake. He comes out to our Santa Monica meetups, and he was saying, design the interaction first. Design the experience first on an interaction level. Make sure that works. And then find a friend or learn how to do 3D modeling. But make the experience feel good first. And the big thing is the ground is constantly changing. WebVR is a specification that shifts. The drivers sometimes fail. When there's always new hardware and the old one falls aside. Things break constantly. So as an example, all those demos I showed you, 2 weeks ago, they all died because of a new spec came out for WebVR. And the community rushes in and fixes it as quickly as possible, but you have to be aware this is an issue. So that's it. I've downloaded all my JavaScript VR knowledge to all of you. You know the Kung Fu. Except for one thing. There's still that question out there. Why would this time be any different? I sometimes pose this question as, why is this not 3D TV? You all remember the craze for 3D TV 5 years ago? We were all going to go out and buy 3D TVs. Every conference was talking about it. Everyone was producing content for it. I'm sure you're going to go home and watch your 3D TV in 3D. I actually asked that question at meetups, at VR meetups, and people look at me like confused and somewhat offended. And they talk about like, oh man, when they try it out, it's transformative. They're definitely going to buy it. And that seems like a real chicken and egg problem. Like, why is this different? Why is this whole experience different from 3D TV or before? And a friend of mine finally knocked me on my head and said why. The big difference is that unlike 3D TV, it's not corporations that are pushing this stuff to us. This thing was kickstarted by us. Yes, Oculus got bought out by Facebook, and like any good cyberpunk story, the corporations are rushing in and trying to control the space, right? But it's up to us to actually go in there and define what that space is. And that's why I've made a point to highlight all the wonderful people who are contributing to this code. So why is this time going to be any different? Hopefully because of you. So please, try escaping into VR, go create some worlds, and share them with each other. Thank you.